Hello chemistry students. This is a video to demonstrate how to draw the microstructures for what you saw in the Petri dishes in the Don't Cross the Line lab. Now remember that a microstructure is just a drawing that represents what's happening with the molecules in a chemical reaction. And the reaction that took place in our Petri dish is listed up here at the top of our screen. We have lead nitrate that is going to react with potassium iodide, and that's going to form potassium nitrate and lead iodide. So over here to the left I have a black box that has a key, and the first thing that I'm going to do is draw my molecules of deionized water, which I've decided to represent as little blue dots. So my blue dots here are the deionized water, and we know that they have covered the entire dish. But how am I going to represent the other compounds that I have in my chemical equation? Well, I'm going to represent lead as a green dot. So I'm just going to draw some green dots here. Remember that you had to put about 6 drops of lead nitrate into the Petri dish. Now remember though that these drops were rather large. You know, 1 drop did not equal 1 compound, 1 molecule of lead nitrate. So there were multiple of those in that 1 little drop. So lead is going to be demonstrated as green, but the lead, each lead is bonded to a nitrate. And according to my key, I'm going to represent my nitrate as violet. So here, the green bonded to the purple dot is going to represent 1 lead nitrate. So we did that on the left side of the Petri dish. Now on the other side of the Petri dish, we added potassium iodide at the same time. So my potassium, according to my key, is represented by red, while my iodide is going to be orange. Like so. So at the very start, we could say that this is what was going on with the molecules that we dropped into our Petri dish of deionized water. Okay, so I just paused this for a second so I could draw in my little molecules of deionized water. But as time went on, so now we're looking at about our 6-minute mark here, and as time went on, the compounds, potassium iodide and lead nitrate, started to move towards the center of the Petri dish itself. So what we would have to draw would be something to show some kind of movement here of the lead nitrate moving towards the middle, and also the potassium iodide moving here towards the middle. And we have to draw our orange here. And then, when they start to meet here in the middle, something interesting happens in our chemical reaction. Notice that products begin to form, namely potassium nitrate and lead iodide. What this is called a double replacement reaction. And what actually occurred is that the lead and the potassium switched places. So here we have lead and potassium, and they switched partners. So that now on the other side of the arrow, lead is paired up with iodide, and potassium is paired up with nitrate. And when that switch happens, that's when you got the yellow line forming in the middle of your Petri dish. So what I did when I paused this is that I took the liberty of going ahead to draw in what actually happened here in our 12-minute Petri dish. So over here you can see that we still have some of our original green and purple. We have our lead nitrate over on this side of the Petri dish, and over on this side we still have some of our original potassium iodide, the red and the orange. But if you take a look in the center, we saw the switch, and I'm just going to erase some of these boxes and other markings so that I can make this a little bit easier for you to see. The actual yellow line is created by the lead iodide, which is represented by a green and an orange dot. So wherever you see the green and the orange, and I'm going to highlight that with yellow here, that was the yellow line that you actually saw in the middle of your Petri dish. But you can't forget that you also have this potassium nitrate that formed as well. The potassium nitrate is going to be represented by the red and the purple dots that are in our Petri dish right here. So you still had those other products that were forming, and you also have a little bit of the originals out here on the edge. So this is what your microstructure should look like for your Petri dish A, or step A in the lab. So now what I want you to do is I want you to use this as a model, and I want you to flip the page over, and you need to draw microstructures for Petri dish 2, step B. And remember that in that Petri dish, you first poured the deionized water in, and then you added one of the chemicals first, waited for about 6 to 8 minutes, and then you added the other chemical to the other side. So you need to show me what's going on with the molecules in that trial. Thank you so much for watching, and don't forget, I am going to collect these on Monday and grade them. So do a good job, use colored pencils, and I'll see you after the weekend.